So this is my lab 2 lines of charges. I'm Daniela. So the objective of this lab is that we are going to create pieces of charge tape. We use glowscript to more accurately show the distributed line of charge. So the result that we got was the tape charge is equal to 9.2 times 10 to the negative 9 coulomb. And the distributed charge was about 8 times the magnitude of the point charge. So some of the fundamental equations that we used were Coulomb's law, which is the electrical force is directly proportional to the charge of the objects and inversely proportional to the distance between them. So this is basically that like charge repel and opposite charge attract. We're also going to use the electrical field force. We're going to use the gravitational force and Newton's second law. So our lab procedure was that we charged the tapes by removing one from the other. So this is what we did in part 1 of our lab. We hung the piece of tape off 2 different chairs at the same height. Then we brought a charged tape under the first tape and watched it float. So we calculated about 2 centimeters of the tape floating. So here are some of our measurements and calculations. So the length of the tape was 0.2 meters. The mass was 2 times 10 to the negative 4th kilogram. The distance was 0.2 meters. The float was 2 times 10 to the negative 4th meters. The force of gravity we calculated by multiplying the mass times the gravitational force. So we did that negative 2 times 10 to the negative 4th times 9.8, which is gravity, times the r hat vector, and we got that as our vector for force of gravity. And then we did the charge of the tapes, which was the F net is equal to the force electrical plus force gravitational, and we got that as our vector. So some of our assumptions was that there was no air resistance, the mass of the tapes are accurately based on the length of the tape, and that the tape had evenly distributed charge. So here's some of the coding. We first established the different constants, which was the charge of the Q proton. We put in our mass and our Q, which is what we calculated in lab 1. And then we did the lines of charges, which that's the code of the lines of the charge, and the electrical field. And so here's the results of the lab. So that first picture on the left is from our lab 1, which was the point charge. And the one on the right is the line of charge, which shows the green is showing the electrical field charge. So some of the questions are ending questions is, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use an experimental data to produce a point charge model to the value you got with your line charge. So the charge of the tapes is about 8 times less than when we modeled it as a point charge instead of a line charge. And the second question was, why do these estimates differ? Which value is more likely to be closer to the real value, and why? So they differ because the model for the tapes as line charge is more accurate than the tapes in real life. Therefore, the value of the charges in the model would actually be more accurate and different. Thank you.